Hello, hello. Hi, everyone. Great to see you all here. Welcome to our webinar. We had a hot topic today that matters to every business using or planning to use AI chatbots. And while we are waiting a while for a few more people, let's do a quick poll. Drop plus in the chat if you already have chatbots for your business, and minus if not. I'm curious to see your answers. Okay, don't be lazy. Type your answers. Great, great. I already can see some pluses. Okay, we have people who already have chatbots. And also we have some minuses as well. Interesting. Okay. Even if you don't have a chatbot yet, most likely you will have it soon, for sure. Here is some statistics or even prediction on how chatbot market will possibly grow next several years. And some statistics on their advantages. And chatbots can be powerful tools for growth, but if not secured properly, they can also become a serious vulnerability. And that's why we are here today. Welcome to our webinar, AI Chatbot Security Frameworks for Business Success. I'm Olha Kolomoiets, VP of AI Engineering at Apriorit, and our main speaker today is Vadym Nevidomy, AI Solution Architect specializing in cybersecurity. And today we'll cover the next items. We'll speak why chatbot security matters. We'll provide some examples of real security incidents involving chatbots. We'll explore some the most popular threat types and discuss the best practices to keep your bots and business safe. Feel free to drop your questions in the chat anytime and stick around till the end. You will receive your answers. And also, we have a great gift for you, a free chatbot security testing checklist. It's the unique document with all the list of essential security tests developed by our QA team. And at the end of our webinar, I will tell you how you can get it. So let's start. Vadym, the stage is yours.
Thank you. Hello, everyone. Let's speak at first about the importance of chatbot security. In 2025, chatbot security have evolved from a technical concern to a critical business imperative. Organizations that are investing in comprehensive security frameworks are seeing remarkable returns on their investment. The business impact is substantial. Organizations with robust chatbot security frameworks are achieving a 320% return on investment. This comes from multiple sources: reduced security incident costs, improved operational efficiency, increased customer trust, and the ability to deploy chatbots for more sensitive and valuable business processes. Customer satisfaction is also significantly higher for organizations with secure chatbot implementations. The average cost of a chatbot breach per incident is now $2 and $8 million. So, multi-layered security frameworks have become essential for enterprise deployment. Organizations can no longer rely on single security solutions. Instead, they must implement comprehensive security architectures that provide protection at multiple levels of the system. Understanding the full cost of chatbot failures is crucial for building the business case for comprehensive security investments. These costs extend far beyond the immediate technical impact and can affect every aspect of business operations. Financial impact represents the most immediate and measurable consequence of chatbot failures. Direct monetary losses from system failures can occur when chatbot malfunction during critical business processes, such as sales transactions or customer service interactions. When a chatbot fails during a purchase process, the immediate result is lost revenue. Reputational damage often represents the most long-lasting consequence of chatbot failures. Negative customer reviews and social media coverage of security incidents can damage brand reputation for months or even years after the initial incident. The loss of brand trust and credibility affects customer acquisition, retention, and overall market position. Operational disruption extends beyond the immediate chatbot system to affect broad business processes. System downtime and service interruption can cascade through interconnected business systems, affecting everything from customer service to sales operations. Real-world case studies provide the most compelling evidence for the importance of comprehensive chatbot security. Here on the slide, you can see several uh, issues, incidents that happen to famous companies. For example, in Chevrolet company, there was an incident that a customer persuaded their chatbot to sell their car for only $1. Another issue happened to Cursor company. Uh, it provided their chatbot provided fake information about their compliances, so it resulted in multiple users. Many users had to delete this application from their computers because of fake information.
Wow, these are really big names. And by the way, there is a recent very loud incident involving McDonald's and chatbot security. They were using a third-party hiring bot, and it led to a major data leakage. Can you imagine over 64 million records were leaked, including names, phones, numbers, email addresses, all the sensitive data from job applicants. And all these incidents involving even big companies, they are just a powerful reminder for us that tools can become dangerous if security isn't properly handled. So let's dive in and let's check how we can um, avoid these situations with our chatbots.
Okay, let's explore major threat categories. First of all, prompt injection attacks can lead to price manipulation in e-commerce systems and unauthorized data extraction, resulting in direct financial losses ranging from thousands to millions of dollars. Data leakage affects 34% of unsecured chatbots, exposing personal information, commercial secrets, and system credentials. GDPR fines can reach 4% of annual turnover, while reputation recovery typically requires 18 months following major incidents. Data poisoning involves injecting malicious content into training datasets, corrupting AI behavior to produce biased or just inappropriate responses. System vulnerabilities create the foundation for other attacks. Let's discuss prompt injection attacks. Prompt injection attacks manipulate chatbot behavior through two primary methods. Direct injection uses explicit commands like ignore previous instructions and role manipulation attempts like I'm CEO of your company and behave differently. While indirect injection methods embeds malicious content within documents or corrupts conversation context that the chatbot processes during normal operation. Key vulnerability factors include insufficient input validation, missing keyword blacklisting, and critically, a lack of separation between user and system instructions. Attacks commonly target financial manipulation in e-commerce systems and data extraction from customer service bots. Prevention strategies for prompt injection attacks must address both the technical vulnerabilities and the operational procedures that support chatbot security. Input sanitization involves filtering malicious keywords and patterns before they can reach the AI model. This includes detecting common structures that might indicate injection attempts and blocking inputs that contain obvious attack patterns. Context isolation is crucial for preventing prompt injection attacks. This involves securing core system prompts so they cannot be modified by user inputs and maintaining clear separation between user contexts and system contexts. When these boundaries are properly maintained, attackers cannot use prompt injection techniques to override system behavior. Access controls provide an additional layer of protection by enforcing data minimization principles and requiring human verification for sensitive operations. Even if prompt injection attacks succeed in manipulating chatbot behavior, proper access controls can limit potential damage. Effective testing for prompt injection requires a systematic approach combining automated tools with manual techniques. This includes boundary testing to probe input validation limits, adversarial testing that simulates real attacker behavior, automated scanning for large-scale vulnerability detection, and penetration testing to evaluate the overall security architecture. Key test scenarios focus on the most common attack vectors. Direct override attempts tests whether chatbot maintains security boundaries when explicitly told, for example, ignore all previous instructions. Role manipulation tests determine if attackers can convince the system to assume unauthorized privileges, while direct injection tests involve malicious instructions hidden within legitimate documents or content. The combination of automated scanning tools and manual red team exercises provides comprehensive coverage, ensuring that both obvious attack patterns and different sophisticated human design exploits are identified and addressed before deployment.
Okay, so as I can see, these attacks are pretty easy. You don't need any programming skills to make them. And I think it's the main reason why they are so popular. What about other types of attacks? Are they so just as easy as prompt injection, or they are more difficult?
Actually, they are more difficult, and so let's take a look at one of them. It's data leakage. Data leakage represents one of the most serious threats to AI chatbot systems. Vulnerability sources for data leakage fall into several categories. Conversation logging presents significant risks when sensitive data is stored persistently in system logs. Many organizations implement comprehensive logging for debugging and analysis purposes, but this can create repositories of sensitive information that become attractive targets for attackers. Integration risks arise when API exposure and database connections that provide direct access to sensitive information. Unsecured APIs can allow unauthorized access to customer data, while direct database connections may bypass normal access controls and data protection measures. The types of data at risk from leakage incidents span multiple categories. Personal information includes names, addresses, email addresses, birth dates, and social security numbers. Commercial information at risk includes customer databases, pricing strategies, and business plans. The unauthorized disclosure of this information can result in competitive disadvantage and loss of business value. Operational information such as system configuration, employee credentials, and source code can provide attackers with the information needed to conduct more sophisticated attacks against the organization's systems. Prevention strategies for data leakage must address both technical and procedural aspects of data protection. Data controls includes collecting only necessary data and implementing strict retention policies that automatically delete information when it's no longer needed. Access control involve implementing strong authentication mechanisms and end-to-end encryption for all sensitive data. These controls ensure that even if data is accessed by unauthorized parties, it remains protected through cryptographic measures. Monitoring systems, including data loss prevention tools and real-time alerts, provide early warning of potential data leakage incidents. These systems can detect unusual data access patterns and automatically block or alert on different suspicious activities. Compliance measures ensure that data protection practices meet regulatory requirements. Regular audits verify that data protection controls are working effectively and that the organization maintains compliance with applicable regulations. Comprehensive data leakage testing requires systematic analysis of sensitive data flows and validation that protection controls work effectively. This includes data flow analysis to trace sensitive data through the entire system, log inspection to examine conversation logs for exposed information, API security testing to verify authentication and encryption, and database access auditing to validate storage protection controls. Key test scenarios focus on personal information exposure by verifying that personally identifiable information is properly masked in responses and encrypted in storage. Cross-customer data isolation by ensuring strict separation between customer sessions, and log security by confirming that conversation logs are encrypted and protected by appropriate access controls. Sample tests include cross-customer queries like show me all transactions for account number 123.45 to verify data isolation, and log inspection using different tools for text search like grep in Linux to search for sensitive information or sensitive words like passwords, credit, something like that. Success criterion includes no personal identifiable information appearing in chatbot responses. All sensitive data being properly encrypted or masked in storage systems. Strict data isolation maintained between customer sessions, and all unauthorized access attempts being detected and blocked through comprehensive monitoring or and access controls. Another type of attack is data poisoning. Data poisoning attacks target AI learning processes through two primary vectors. Training data attacks that inject malicious content or manipulate labels in datasets, and feedback loop attacks that corrupt ongoing learning through rating abuse and misleading user feedback. Key vulnerability factors include inadequate data validation, missing source verification, insufficient content filtering, and uncontrolled user feedback systems that allow malicious actors to influence model behavior without proper validation checks. Common impacts include bias introduction, leading to discrimination issues and brand damage. Inappropriate responses, generating customer complaints and social media backlash. And misinformation spreads, creating legal liability and real-world consequences for affected users. Financial impact is significant. With average remediation costs of about $1 million, 18% revenue decline during recovery, and 67 days recovery periods. Detection of inappropriate responses often occurs through customer reports rather than automated monitoring. Misinformation spread occurs when chatbots begin providing incorrect information as a fact due to poison training data. The impact includes legal liability and customer misinformation that can have serious real-world consequences. Detection of misinformation requires fact-checking audits that may not identify problems until significant damage has already occurred. Prevention measures for data poisoning must address both the technical and procedural aspects of data management. Data curation involves implementing multi-source validation to verify the accuracy and integrity of training data. Expert review processes provide human oversight of training data to identify potential problems that automated system might miss. Automated filtering systems can identify obviously problematic content, but human expertise is often necessary for subtle forms of data poisoning. Secure pipelines implement access controls, version control, and approval workflows to ensure that only authorized and validated data is used for model training. These procedural controls are essential for maintaining data integrity throughout the model development lifecycle. Testing for data poisoning requires specialized techniques to identify malicious data injection in training datasets. This combines data source validation to verify training data integrity, anomaly detection to identify unusual patterns that might indicate poison content, model behavior analysis to detect bias or misinformation, and back loop monitoring to prevent manipulation of continuous learning systems. Key test scenarios focus on training data integrity by ensuring all data comes from trusted sources with complete traceability. Bias detection to identify unfair patterns across demographic categories that could indicate poisoning, and feedback manipulation testing to maintain the integrity of user feedback systems against coordinated attacks. Testing frameworks include data validation tools like proven trackers and source verification systems, plus model evaluation tools such as bias detection suites and adversarial testing frameworks that can identify the effects of poison data on model behavior. Now let's examine our comprehensive security frameworks overview, which provides the foundation for protecting AI chatbot systems across 4 critical domains. Data encryption and protection forms the first pillar of our security framework. We ensure all communications and data are encrypted. End-to-end encryption protects sensitive data throughout its entire lifecycle. Regulatory compliance represents our second critical domain. We maintain compliances to ensure sensitive data protection adherence. Authentication and authorization are key to controlling access in chatbot systems. With measures like multi-factor authentication, role-based access control, and secure API key management, ensuring that only the right people and systems can interact with sensitive functions. Monitoring and incident response ensure real-time threat detection and proactive defense through security information and event management. Intrusion detection system and regular vulnerability assessments across the infrastructure. Our security framework architecture implements a comprehensive layered defense strategy, with each layer providing specific security controls that work together to create robust protection for our chatbot systems. At layer 1, network security forms the outermost protective barrier. This layer includes firewalls and network segmentation that control traffic flow and isolate different network zones to prevent lateral movement by potential attackers. Application security focuses on protecting the software components of our chatbot systems. Input validation and sanitization ensure that all data entering our applications is properly screened and cleaned to prevent injection attacks and other input-based vulnerabilities. At layer 3, we have data security that protects the information that our chatbot systems process and store. Encryption at rest and in transit ensure that sensitive data is protected, whether it's being stored in our databases or transmitted between system components. And the last layer is identity and access. It manages who can access our systems and what they can do once authenticated. Strong authentication mechanisms, including multi-factor authentication, ensure that user identities are properly verified before granting access. This layer architecture ensures that even if one security control fails, multiple other layers remain in place to protect our AI chatbot systems and the sensitive data chatbots process. Now, let's explore our comprehensive framework for implementing safe chatbots with large language models. This framework consists of 5 critical phases that work together to ensure robust security and reliable performance throughout the chatbot lifecycle. At phase 1, we have input validation and output filtering. The first phase focuses on establishing strong boundaries for what enters and exits our LLM-based chatbot systems. Content filters are designed to identify potentially harmful inputs that could compromise system integrity. Pattern detection systems identify attempts to override system instructions through various manipulation techniques. At phase 2, we have guardrail implementation. The second phase implements sophisticated guardrails that provide intelligent content analysis and behavioral monitoring. Content-based guardrails utilize advanced keyword detection and semantic analysis to understand not just what users are saying, but the intent and context behind their requests. The third phase ensures that all data handling meets the high standards of privacy protection and regulatory compliance. Data minimization principle ensure that we only collect necessary information to reduce both privacy risks and the potential impact of any security incidents. Encryption protocols protect data both in transit and at rest, ensuring that sensitive information remains secure throughout its entire life cycle within our system. Data retention policies define appropriate storage timeframes, ensuring that personal and sensitive information is not kept longer than necessary for business or regulatory purposes. The fourth phase implements comprehensive testing methodologies. to validate security controls and identify potential vulnerabilities. Adversarial testing includes red team exercises with creative prompt engineering designed to test the limits of our security controls. These exercises simulate real-world attack scenarios to identify weaknesses before they can be exploited. The final phase establishes ongoing monitoring and continuous improvement processes to maintain security effectiveness over time. Real-time dashboards track guardrail activation rates. They allow security teams to monitor system health and respond quickly to different emerging threats. This comprehensive five-phase framework ensures that LLM-based chatbots are implemented with robust security controls, comprehensive testing, and ongoing monitoring. The framework is designed to be interactive, uh, with insights from the monitoring and improvement phase feeding back into earlier phases to continuously enhance security posture and system effectiveness.
Okay. Thank you, Vadym. I'm sorry for my voice. If it's still bad, I tried several things. I received your comments. Thank you. Thank you for letting me know that something wrong with my voice. I hope it's better. If not, sorry. Thank you, Vadym, for this lecture. It was awesome. A lot of information. Now we know how to build security chatbot. Looks like it's not easy. And it's time for gifts. It's time to get your bonus. If you want to get our security testing checklist for chatbots, just write checklist in chat, and I will send it after the webinar. And now it's time for your questions. Drop the questions. By the way, if you're watching this webinar in recording, you can contact me on LinkedIn and I will send you the checklist. Time for your questions. And while we are waiting for your questions, I have one question from my side for you, Vadym. Okay, what are the minimum set of security measures you would advise for basic security setup for a chatbot?
Minimum security measures would
Mhm.
include data protection measures, encryption. So all data stored in your system will be encrypted. Also, strict authorization and authentication rules to not allow LLM-based chatbots to perform any action in your system. And probably guardrails if it's important if it's specialized chatbot for different news websites where correct information is very important. You need to have set of guardrails to perform kind of fact checking before providing response to user.
Okay, thank you for your answer. And we have another question. It's long, I will read it. As I know, training on LLMs is hard and expensive. It's hard and expensive work required some expertise. So most of LLMs used in chatbots projects are from open source projects and potentially can contain some hidden logic activated by secret keywords. My question, how can we define that the LLM is safe for using? Is there some green marks for LLM or certifications? Great question.
Okay. Actually, trained chatbots, trained LLMs are large binary files, and you can directly see what is inside. So to make sure that it's safe, if you're really concerned about that, you have to perform comprehensive testing for your scenarios to ensure that it's safe and provides good quality output. Actually, uh, if you want to use open source models, you're not uh, safe from different malicious content in those binary files. But many open source models are produced by large companies like Microsoft, Google, OpenAI, and I think you can trust them if you're concerned, and you can choose from uh, uh, large verified companies. You should choose LLM if you want to use open source one. But if we speak about closed LLMs, then they go through comprehensive testing before going into production. So you can be sure that they are safe enough.
Okay, thank you. And another question, how do you validate that an input is a bad input from a user? Is there some sort of thresholds, and or how do you deal with false positives?
Okay, there can be a large set of different guardrails. It's a component that sits between user and LLM. And when input from the user comes, it goes through a list of guardrails. It could be these guardrails could be LLM based. They could be using strict algorithm, like by some different blacklisted keywords present in input. Uh, and LLM-based guardrails are more sophisticated, and they're focused more on intent, on user intent. For example, if they want to do prompt injection or do some other stuff, there could be a long list of checks before sending input to our LLM. How to deal with false positives? With our monitoring solutions, we collect all guardrail activations and user inputs for further analysis. This analysis could be semi-automated with later human verification. And if it's our own LLM or open source LLM, we can fine-tune it with uh, uh, special cases where we see that it's false positive. If it's false positive caught by guardrail, so input was actually good, but it was blocked because our guardrails thought it was some malicious content. We can tune our rules. And all these rules should go through comprehensive testing. And these of previously false positive scenarios should be added to test lists.
Okay. Another question. What are your suggestions on implementing the moderation system that can detect and prevent the generation of harmful or inappropriate content?
It's related to previous questions, but it's about now about output guardrails. So we validate not only what gets into our LLM, but also we validate what LLM generates. We can, using prompt injection, for example, we can persuade LLM to answer in a harmful way. But we don't want our system behave like that. So there will be a guardrail that filters outputs generated by LLMs, validates it, and only if it passes all the checks, then it will be sent to the user.
Mhm. And one more question. How do we ensure chatbot compliance with data protection laws like GDPR, HIPAA, or CCPA?
If we speak about if it's LLM-based chatbot, we should distinguish two possibilities. It could be a SaaS LLM provided by, for example, Azure, Google, and usually they have SLAs that guarantee you that certain compliances are met. So all data that you send to those LLMs, even companies can deploy LLMs on-prem on your environment if you have very sensitive data. So usually large providers have certain SLAs and compliance is supported. If it's open source LLM, it's running on your environment, you should strictly do regularly reviews of security measures in your system, because data is stored in your servers and it can be leaked from any place. So you should provide regular audits of your environment, of your infrastructure, do security and penetration testing for such cases.
Okay, and I can add to this answer that even if LLM is like compliant, we need to build the solution compliant as well, and we should do testing, we should do encryption, we should follow all the compliance items. Okay, another question. We know that black box model concern. How to mitigate this issue or incident monitoring guidance?
Not sure I understood about Black's model concern. It's about that we don't know what is inside the model, how it behaves. I guess so. How coincidence monitoring guidance. So we should consider at first. Anyway, our data goes into LLM model, and we should be sure about its guarantees that this model provides. If it's open source model, you may not have such guarantees, so I don't recommend using them for high security projects. But if it's models from, for example, AWS government section, that they provide very strict guarantees, and your data will be safe. Incident monitoring guidance, also there are several solutions for that. It may include alerts from your guardrails when something serious happens. Your guardrail can have a severity for some incident, and alert will be sent to immediately. If it's human-based incident, for example, you have some kind of feedback system in your project, and um, real human wants to connect. Basically, you should have a button connect to real person, because if he doesn't want to speak to AI, or it can have scores, something like that. It's also kind of alert that is sent to monitoring system, and all such alerts can be configured differently for many rules. For example, if you are concerned with long responses, because it will take all your money for generation, you can have a separate guardrail for that and block those users immediately, or provide some rate limiting if a user intentionally makes your LLM to output huge contents of text.
Okay, thank you. Thank you for this answer. And we have another big question. I will not read it at all. Yes, we have a person who wants to develop his first chatbot, and he asks if using Razor to build a domain-specific chatbot for a watcher company is a good tool or not. What do you think?
Actually, I haven't heard about this framework. I'm not sure what it is. I guess it's some kind of um, a RAG library that helps incorporating private data to LLM. But if it's possible, can you clarify what this library does? Uh, uh,
Yeah, probably I have another solution for this question. We can arrange a call with you and go through your requirements, what your chatbot should do, what do you want from it, and we can advise you proper instruments and proper frameworks to build the solution you need. Just contact me on LinkedIn, and I will arrange time with you. Okay. Any other questions, comments? Thank you all for visiting us. Thank you for attending. I think that's it. If you have any other questions, don't hesitate to write me. I'm always happy to answer. Have a great day, evening, night, whenever you have. Thank you. Bye bye.
Thank you. Bye.